Hello, everyone. I'm on this side today. Hello, how is everyone? Hello, Docadia. Hope you're well today. Uh, this is my first time doing a dev stream. I'm doing actual coding, so it's probably going to be tough, but see. Quite finished setting everything up yet because fingers. I should have done it last night, but I was a bit busy. So there's going to be a bit of some rough edges around. Up until 5 a.m. Well, you're playing No Man's Sky. Okay, understandable. Have a nice day. Send out my tweets. I think. Yes. Okay. Forget to get one win. So let me get that. Okay. Hope that's what across here. Okay. 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 We're back. Yeah. Right. So I hope you all had a nice week so far. If I saw you Monday, hello again. We are going to be doing some coding in a bit, but first I'm going to talk about what I'm coding for, just to add some context to what I'm doing here. Papercut Doctor has kindly demonstrated the command there, so yeah, just so we can, we'll throw the link to the website that I'm about to show, basically. The Megaprocessor itself, let's see if this works. I set this up literally as stream went live. I press this, bam, okay, website. I'm on this. I'm used to being on the other corner. It's over this side. So this is the Megaprocessor, just this entire thing, straight from far side all the way across. And I think there may be actually another panel that's not on. Basically, this mad lad, this absolute mad lad, decided to build a processor, but instead of being on the microscopic scale, it's now on the macroscopic scale, as it were. So he's built a processor. So instead of being contained on a silicon wafer, like really tiny, everything's super big, made out of, you can visibly see, like, these gates here are normally on the nanometer scale in your processor. Like when people talk about the architecture of a CPU and they say, oh, it's using this nanometer, this is what they're talking about. Talk about the size of the the gates and things like that. That's how big, roughly, that's what they're talking about. So the smaller, generally, the lower power it takes to operate it, and generally they get faster within limits. So this chungus of a machine here is a 16-bit processor, basically expanded out so you can see each of the components. There is a video here. I'm not going to play the video through video because I don't like doing that. There's some more zoomed in shots here. But these are some of the panels here, and you can see the wires showing the circuitry where it would be. General purpose resistors, I'll get into those later. We see a diagram of those later. But the memory here is the important bit as well. Sorry, I'm pointing the wrong direction. Over here. So each LED represents 1 bit of memory. 0, 1, on, off. But because it's done like this, you can use it as a screen. So you can output by drawing stuff in memory. But you only have 2 colors. You have on and off. That's it. That's all you've got. Some more stuff there. Let's get into the nitty gritty. So, sorry, it is a bit bright. This I forgot to attenuate this before stream, so probably if I just burn your sockets out. This website was made probably 6 years ago at this point, so dark mode wasn't a thing. So the processor basically has this available to it. Yeah, it is on the. It's just trying to think of anything that small. It's just so the ALU, the I think it's arithmetic logic, basically has access to 4 registers there, R0 through R3, and it can do things with those. So it can add them together, subtract them, in some cases multiply and divide, or it could do bit shifting left, right. What else can it do? It can compare, which is basically subtraction without actually doing subtraction. And then the PS here is the processor system flags, I think it is. So that tells that basically logs whether when a mathematical operation takes place, what actually occurred. So was the number negative? Was the number 0? Was the number was there an overflow generated? Was there a carry bit? Things like this are all stored in the PS register. Which is PC down here is the program counter. So you've got a whole list of commands the processor needs to run. The program counter tells the processor which one it's currently doing. So basically, every time it does an operation, unless you're telling it to jump somewhere, it'll add one to move on to the next one. You can tell this to jump to another place in memory. So that's basically it. And then here are all the different instructions that the processor can do. So we've got things like adding, got ORs, XORs, move, which is basically just moving stuff between the registers, negate, subtracts, the different break commands, which is just way of forking code. And you got the very precious divide and multiply commands here, done in hardware, which a lot of old processors couldn't do. You'd have to do this quote unquote manually. But the person who did this, like I said, was a mad lad and gave us multiply. We even got square root here. I don't fancy working that out manually in assembly. And good old NOP, which is no operation, means do nothing. Big fan of that one. So yeah, and then all the other instructions and a few other things are all listed here. So the way a processor works, probably with some exceptions, there's always going to be exceptions, is it works on a fetch, decode, execute cycle. So the processor fetches the command, decodes what it needs to do, decode, and then runs that command. Yes. So that's basically what a processor does. It fetches the next command, works out what that command actually means, executes that command. It then goes back to the start. Modern processors much more complicated and have pipelines to allow faster execution rather than going through. It's no, just we're not dealing with that now. Luckily, this is just a simple fetch, decode, execute cycle. Don't need the instructions. Let's go. Let's have a look at some code. Where's my buttons? I've lost my buttons. That's not my button. Here are buttons. Okay, here we go. I forgot. That changes it for OBS. It doesn't change it for me because that'd be convenient. What's my code? It is. Okay. So some of you might be familiar with code, might not be. That's fine. There are many programming languages out there. But the closer you get to the coding for a particular processor, the more similar they tend to get. Most processors can do very similar things. They need to, like, you need to be able to add two numbers together, be able to subtract and like this. And these are all done. They might have different actual decode values, but they can generally all do that. This is what, when you see things, processors have different instruction sets, that's what they're talking about. That processor can do some things directly that other processors can't. Yeah, I don't know what's going on, but yeah, that's basically what an instruction set is. It is a set of instructions the processor has access to in some way or form. So I've started writing this program, which is in assembly language for this processor. Now, the chances are this assembly is this assembly language is unique to this one machine because there are no other Megaprocessors that I know of. There's only one, which is housed at the Cambridge Centre for Computing History. Again, if you're in Cambridge, definitely set an hour or two aside to go visit. You like old computers, you like old consoles, go there. Right now, no, not right now, they're closed, but you know what I mean. So this language is probably only going to be executed on that one machine. Now you're probably thinking like, well, how do I run the code then? I don't have a Megaprocessor in the void behind me. For that, we use a simulator. I'll get my buttons back out and I press this button. Bam! Simulator. So as you can see, now I have attenuated the colors down a little bit because, again, this program was written before dark mode was a thing. So rather than blind you each time I switch, I've lowered that. If you can't read something on it, apologies, but it's better than burning your retinas out when I switch. So as you can see, the RAM LED... Oh, sorry, I didn't start my music. As you can guess, we're going with FTL today. My bad. So on the far side here, you've got the RAM lights. So those are that panel with all LEDs on. That's what that is over there. At the moment, it's full with garbage data, which is why it's just scattered dots everywhere. Then you have the disassembly, which is where my code would be, or any code that I load into it will be. Way above me, those are the registers we talked about. So R1 through R3, you can see them there. They say CD in them currently. And then a bunch of other things to do with the state of the processor. So we can watch those change to make sure things are working as they're supposed to. And then behind me are the controls. As you can probably see, it's probably hooked into some PlayStation pad, given the symbols used here. So that's how we can simulate my code running on the processor without... Did I get quiet? Did something change? If someone could confirm whether I might have leaned further away from my microphone when I changed. I moved position. Okay. Okay, thank you for confirming. So we're going to run the code on this, which simulates it running on the actual machine. Hello, Bear. How are you doing? Hope you are well. Why that command not work? That's because you typed the name wrong, I think. There's an S in there somewhere you missed. I do like the exclamation point by Odin's beard. The other one I like is by the power of Grayskull. There we go. We got it. So that's how we're going to run the code. We're going to run it on this, and that should be, assuming Great Scott is another good one, yes. It should be just like running it on the machine physically there. Hopefully, when I get this running, I can take my program to the machine, copy the program across, and it should just Todd Howard. It should just work. Note the word should in there. I don't know how accurate this simulator is. It could be. It's made by the same person who made the machine, so I suspect it's accurate. But you never know. So I put the word should in there. It should work. I'll take my laptop with me and do some last-minute debugging in case it doesn't work. As a demonstration, I'll load in one of the test programs that comes with the simulator, so you can see it basically running. Give me a moment. This one? Ow, that's bright. It's not bright for you guys, but it's bright for me. I'm to load in. So I'm going to now run. So the code wipes the memory and then draws this little snake guy. You can see on the far side there, a bunch of red dots going down, and it should hit the bottom and then drop down, change direction, and then goes all the way back up again. That's literally all this program does as a demonstration. So as you can see, all the way up there, the processor is furiously crunching through data. Like the registers are quickly changing, like rapidly as it's doing all this. This is a fairly simple program. It's just moving the snake around the screen. It's called snake, whichever. I didn't write this. I'm going to say that now. I did not write this program. I borrowed some of the code to do what I'm doing because, well, if it's good code, I'm gonna fuck it, aren't I? Right. So that's what it's gonna look like. I am making the old Atari game Breakout for this machine. So let me load in what I've got so far. Damn well worked now. I'm looking like an absolute pingus. So here we go. Drawing the grid. And it crashed. Didn't do that before. Thanks. Question is, why did it crash? That's actually a good question because this was working before. Now it's not. Wonderful. Hello, Joe. How are we doing? I suspect. Were you doing art? We're usually doing art when I pop in. You're well today. Everyone else that's joining, welcome. We're doing some programming here. Apart from, I've already broken it. I've not even written any code today. Great. Hello, Tristan. I am writing assembly code for a unique processor. Apart from, I've already broken everything, which isn't a great start. So let's set. Okay, give me a moment. I am going. Something's not quite right. I'm gonna pull a backup down because I think something's wrong here. Otherwise, we're gonna start this with a debugging session, which is not a great way to start the stream, but I'll take it. Sadly, I can't show the actual compile process here because OBS can't capture from command prompt. Who knows why? Because I don't. Apologies for the scuffed here. Let's see if we fix this. Let's reload. Actually, the right. It is. There we go. Right. Okay. I've pulled it from a backup. Evidently, I must have done something wrong. So you can see, I've got a board up the top. I've got a paddle down here. And there is a flashing red ball that's going up. It's going up and down here. I can't see chat right now. Debugger? No. Okay. Oh, hydrate. Thank you very much. Check that. Oh. Bit of instruction there that says add, so I think the program doesn't work this time because it has add. Yeah, you're not allowed to add. It's a unique program where you're not allowed to add anything, but if you subtract a negative number, it's the same as adding, so you can still do it. Don't know why you would do that, but sure. So, what do we have working so far? Well, we've drawn to the stream, we've got a board. We've got a ball that can move vertically. It can collide, so it's got vertical collision. We don't have horizontal collision yet. We might work on that today. But it moves up and down. That's like 50% of the things it needs to do, right? And then we've got a paddle down here, which I can move. It should crash on me now. So, yep, we can move it left, and we can move it right. So, oh, right. Well, this is basically the game, right? We just ship this. Do we need to write any more code? I think not. So, this will just loop now. This just does its thing, loops. It's not particularly efficient code. Like I say, this is the first time I'm writing assembler for an actual processor. I've done coding like this for video games. So in games like Exapunks, Shenzhen IO, basically Zachtronic titles, where they have an inbuilt language for their game, and you have to write that. What's the TAS 100 is the other one. Those are the three big ones that I know of, where the game is basically write code for this strange language. Assembly is basically the real version of that. I'm just going to put my fan on. It's a bit warm in here. All this talking and gesturing. I feel like Stan from Monkey Island. So let's switch back to my code. Cheers. No. And for you guys, it's yeah. So, how does this work? For anyone that doesn't know or do programming, generally speaking, programs start at the top and they work down. The processor will just run command after command after command after command as it is. So program flows from top to bottom. Hopefully I've zoomed into the screen enough for you guys to see it. I probably have a bit more to spare before it starts to get a little bit ridiculous. So if you're having trouble reading anything, please just let me know. So first off, we need to assign memory to variables that we need to change and keep track of. Things like, am I capturing the mass? I am capturing the mass. Okay, so like where the ball is in what the ball X coordinate is, what the ball Y coordinate is. So because that's something that changes, it's variable, but I need to keep track of it. We have constants as well, so things that don't change. So how big the board is in terms of memory, how big the paddle is, we can adjust that just by changing its number. All great and dandy, wonderful. So the actual code starts here where it says the program. So we set the stack pointer, which just tracks jumps. Don't worry about that for now. To a known value, so we know where we are. We then initialize everything we need. So we set up the board, so that's why that all draws from the top to the bottom, because it's basically going through the memory addresses and setting that up. and then clears the rest of the board, and then it draws the paddle, sets up all the default values like where the paddle is, where the ball is, what direction the ball's moving at the start, things like that. And then we've got the core game loop here. As you can see, not much going on here yet, because it's not much of a game. So we've got input check. We need to check whether the player has pressed left, pressed right, or is not pressing either of them. And we do that by looking at a particular place in memory, saying, hey, what's the value of this bit? Are they pushing left, or are they not pushing left? Pushing right, they're not pushing right. We do that via these registers here. So as an example of what these commands do, we'll look at this. So this is load. LD is the, what do they call it? There's a word for it. I can't remember what it is. An acronym. There's a word. Someone remembers what it is, please tell me, because I can't remember. Dot word, so it's loading in an entire word. In this case, that's 16 bits of information. A byte on this, a byte is always 8 bits. I don't think that's ever been defined differently in other programs, but the word length is different per processor. Some machines deal with 16, some deal with 8, which is just basically the same as a byte. Some deal with 32 or 64. That's their word length. So basically, what this little bit of command here, are we pressing left? If so, jump to the code that makes us move left. Then it checks to see if we're moving right. If we are, jump right. Once that's done, it comes back to here. So if none of those trigger, it just drops straight through into this. And if it does, it will jump back to this. Because obviously you can't move left and right at the same time. It's a joystick they use there, so you can't physically do both. But if you could do both, it would only do the left input, because it would jump at this point. So left has priority over right, technically, but you can't do both on actual hardware. In fact, you can't do both in the simulator. Then we store what the last game tick is. Now, the reason why we want to keep track of the game tick is because we want to make sure the game doesn't run too fast. Because if the ball moved whenever it reached the redraw ball command, it would be updating it many times a second. And it would just be unplayable. So if we store a game tick, then we know it's time to update when the ball is. So we can adjust the length of the game tick to speed up or slow down the game. Unfortunately, we are processor limited here, so I suspect my code will be not executed particularly fast on the machine, because this is my first time using assembly on any processor for myself. I've written emulators before that used other processors and other people's codes. This is the first time I'm really writing it for myself. So if you are watching and you're an assembly expert and you're looking at my code going, oh my god, what are you doing? That's why. I fully expect my code to be what is known as bad. But it might work. So, yeah. And the halt loop here is so I can stop the processor doing something when something happens, so I can check states. So this generally won't be reached unless I force that event. Because I don't think there is a halt command instruction set. It might be, I just didn't check. And then the code here is move left, move right, which are basically the same code, but obviously the way the paddle moves, it doesn't redraw the entire paddle. The paddle only moves 1 pixel, for lack of a better word, per movement. So instead of deleting the entire paddle and then redrawing it somewhere else, all it does is it erases 1 pixel off one side, adds 1 to the other, simulating it moving 1 pixel. So that way we have fewer draw commands to the screen. We don't have to delete 5 and add 5 back on. It just deletes 1, adds 1. And same for the other direction. Deletes it on one side and then adds it, or deletes then adds. That's an optimization that you can get away with. And then we've got collision, because obviously if you're moving the paddle left and right, if you scroll your paddle so far one way, you don't want it going off the edge of the screen. So this code here is to make sure that when that happens, it basically draws it in the correct place. Collision right is the same, but on the other side. Yep. These are done by like, oh, what's the value of my x coordinate? So we add one. We find out what the value of x is, so where it currently is. It then increments it by 1 to simulate it moving right. We then load in what the max value is, and then subtracts the 2. If the BMI command breaks if minus, so if we are too far across, i.e. the number is too big, there's been a collision on the right side, we jump to the right code, and then we reset the variable back to where it should be, and then we say we're done with movement, jumps away. That's it. Job's done. The actual draw code, this is the bit that I acquired from the other program we just looked. This code here. This basically, I give it an X and Y coordinate of a pixel and it flips it. So if it was on, it turns it off. If it was off, it turns it on. Though the original instructions did not tell me this. It implied it only turns the dot on. What it actually does is flip the bit. So if it's on, it turns it off. If it's off, turns it on. Not like that, Tarcadia. So, what's the plan for today? Good question. Let's see if we can get horizontal collision for the ball working. Update ball. Okay, luckily, someone left some comments here. Not enough, I might add. Naughty past me. Always comment your code when you can. So, what I am going to do, first off, instead of making the ball move left, up and down, we'll start it moving left and right. Let's have a look. That's here. So these should really be constanted, but So what I've done here is before it was loading the R0 with the number 0 and then assigning it store word to ball speed X. So before it was moving 0 in the X direction. And before it was doing Y 1. So it was moving, going down the screen is positive. Going up the screen is negative. Kind of counterintuitive because most people know graphs where the origin is in the lower left corner. On this screen, and quite frankly, most screens, upper left is 0, 0. So, and then you increment to go left and right. So it's, yeah, that's just how it works. Yeah. So we've now made the ball go left and right. That was easy, right? The problem is it needs to collide with the walls of the screen. So it needs to not go negative and not go above maximum. So here's the update ball. So let's I wrote this when it was like 30 degrees C in the room. So forgive me if I've forgotten what it does. Again, past me, should have wrote better comments. Didn't. Oops. First off, we're loading in the ball's X and Y coordinate. We do need that. We then erase it because it's always on the screen. So we do a draw point command. So that will delete wherever it is because the ball should always move. So we erase it from the screen. And then we need to calculate its new position. So then we move the ball in the Y direction and test whether it collided. If programming language needed comment, it's assembly. You are 100% right, Napster. You are 100% right, and I hope you're doing all right. So, first off, we load the balls X and Y back in. The reason why we do this, you might think, but surely, Omni, the data's already there. The problem is, those are loaded into registers, and this subroutine is just a block of code you can jump to and then return from. So it just goes somewhere else in the code and then comes back here. If you don't go sub a program loop, you'll never get a subroutine. Now, if someone can tell me where that is from, bonus points to you. So the thing is, the processor does things in that subroutine, so we don't know that the values in R0 and R1 are still going to be the same when it comes back. The answer is, in fact, Red Dwarf. Yes, Darcadia got it. It is a quote from Red Dwarf. Can you tell me what episode it is, though? Go on. For more points, tell me what episode it's in. Yeah, so we load those values back in. We then get the ball's Y speed because we're moving it in the Y direction. Yeah, that's right. So we have to check one of the directions first. So I've chosen to do the Y direction because that's the easiest one to do. Napster's just resubscribed for 12 months. Thank you, Napster. No, I've had a bit of a break recently. It's good to see you back. Lost track of where I was. What was I talking about now? Oh, ball position. Hello, Cobbler. How are you doing today? Ball direction. I didn't know you streamed. I don't even know what that is. Do you stream, Cobbler? You did once a year and a half ago. It's not what I'm familiar with. Sunrise is not really a game that I like, a genre of games I play. I mean, I did play a lot of Tenchu Stealth Assassin. Not samurai, they're ninjas, I guess. But game's cool. Oh, and it was in the episode Justice, I believe. I think it's the same season as the episode you think it is, but I'm pretty sure it was in Justice. Anyway. Code. So we add ball speed to Y. Well, we add it to R1 to R2, so add speed to Y. We then get we then store the X and Y coordinates of where we want to check. Then we jump to a piece of code here which checks point. What does this do? Oh, look at this commented code. Look at past me go. Well done. Well done. So checks to see whether we've got a collision. We need to see whether a point in memory is a bit in memory is already turned on or off. If we try and set something that's already, if we check that bit and find it's already on, it means something was there. It hit something. That's fair enough. So first off, we load in the start of the memory pointing at the screen. We then work out which byte in memory. Let me switch to Sim. So it's still running, by the way, in the background. So if you may be able to see this on the stream, I'm not entirely sure. Sorry, I'm pointing the wrong way again because I'm on the wrong side. I'm usually in the other corner, not this one. Each row in the RAM LEDs is separated by a line every 8 bits. So there are 4 bytes per row of memory. So we need to know which byte the bit we're checking is in. And we do that by multiplying the value by 3. But if we go back to the code, no, not by 3, by 8, sorry. Blah, 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 blah. What am I talking about? I do know what I'm doing, chat, I promise. But I say that. But I do know what I'm doing, kind of. If we go back to the code, you might see, well, where's the multiply command? Little trick for you. Just wait. Like a voice. I'm in. How you doing, Zeus? Hope you're well. I do love that emote. Which is that? Just derp? Yeah, Poffle derp. Great. Can I get a shout out for Zeus as well, please? Because he's an absolute bean. So, if you want to multiply something, okay, let's think of it in terms of normal numbers. So, 10 digit numbers. Sorry, as in 0 to 9 numbers. The way everyone apart from the French count. That's unfair to the French. They just have a very weird counting system. But so when you want to multiply something by 10, which is the same as the base 10 number, what do? You slap a 0 on the end, don't you? And you move it along one space. So 10 times 10, whoop, 4 20s, yeah. No, you made me say that was 4 20s. Ah, tricked. Right. So 10 times 10 is 100. So what you've done there, you shifted the 10 across and added a 0 on the end. Super easy. What do we want to do if we divide by 10? We just take the last digit off and move everything down 1. Yeah. You can do the same in base 2, which is binary. So if I want to times by 2, I shift everything to the left 1 slot. If I want to divide by 2, I shift everything the other way by 1 slot. Works. If you're doing the same calculation, multiplying or dividing by the same number that the base is, you can do that trick. It's great. So if you want to move by 2, 4, or a multiple of, 2, 4, 8, 16, really easy to do. This command here is left shift. No, sorry. Ignore me. Logical shift right is what that means, LSR. So we divide by 8. That's how we do that. Yeah, we're moving right. Logical shift right. So we're dividing by 2, then 2 again, and then 2 again, which is the same as dividing by 8. Nice little trick there. I didn't realize you could do that. It never occurred to me until I started writing an emulator and learning tricks like that. It makes sense once you realize that's what you do. Well, that's how you learn to multiply by 10 when you're like in infant or primary. I can't remember when you learned how to multiply, but you literally move from the tens column to the hundreds, the units to the tens, and then add a 0 in the units. It's exactly the same operation. And when I realized that, I was like, how did I not realize that before? But that's true for any base calculation. If you're multiplying or dividing by the same number as the base, you can shift. That's just how it works. So then we work out the offset to work out where everything is, and then we mask off which bit we want. And then we AND them together. So we check to see whether the bit we want is on, and then we return. This AND command will set the Z flag in the processor if there was a collision. So if we go back to where we were, also I forgot to bob then, that was my bad, that's me terrible. I'm not listening to my own music, too busy talking. We then immediately do a break if not equal. Break if equal, sorry. So that checks to see whether there was a collision. If there wasn't, we confirm the ball has been updated and can move. If it doesn't break here, it continues saying, oh no, there was a collision. And then what we do is we reverse the direction of the ball, put the ball back where it was, because it's obviously hit something and now we're bouncing off it. So again, we load in the ball's speed, we then negate it, so we basically switch it. If it's positive, it's negative. If it's negative, it's now positive. And then we update all the values in the variables, and then we say we're done, redraw the ball. What we need to do now is change this logic so we're now checking left and right. You may notice there's a slight problem with this code. It's probably more than a slight problem, if I'm honest. But one of the problems with this code is it doesn't check to see whether it hits the top of the screen. It also doesn't check to see whether it hits the bottom of the screen. It's only checking to see whether it hits a game object, i.e. something drawn to the screen. We'll fix that later. In fact, some of the code we're using now can be recycled later to do that. So we're going to assume there was no collision. So what we're going to do here is we are going to start another code block, and it's going to be check ball X. Why not? Now, the reason why I'm putting a not there is because if I forget to put something else in here and I run the compiler complains at the fact there's an empty code block and it goes, Ugh! That's fine. I just, out of habit, I put a NOP in there now. If I forget, that doesn't do anything. NOPs are literally no operation. The processor just sits there for a cycle, maybe 2 cycles, and goes, taking a bit of a break. Sorry, chat, I need to get more drink. Be right back. Chair's in charge while I'm gone. Right. Oh god, pixelated rainbow everything. Jodak. Yes, it's a latest game from Ubisoft, Rainbow 5 Chair. I've got just realised I had a message I should have replied to. It is a picture of a cat. I cannot show it on screen because it contains someone's name. So, but it is a cat, and it looks cute. So sorry, I got distracted there by cat pictures. I mean, who doesn't? I mean, it's the internet. Cat pictures. Right. So first off, Oh, we can't do that. I thought of a trick I could do that, but right. Okay. So instead of doing something when we're that, we're going to jump here instead. We're going to check the X direction. We'll do the same again. We'll make sure the variables are correct. We load in the ball X and ball Y coordinate. Do we need the Y coordinate? We're only checking the X direction. Actually, that is a good point. We could optimize this slightly by not loading in. No, it's fine. It's fine. It's fine. It's fine. Get it working first, then optimize. That's just how I play Zachtronic games. Get the puzzle working, then make it look beautiful. And or optimize the shit out of it. Apologize for swearing, but that's the technical term. Okay. Okay. By the way, this is 90% program. We'll just copy paste to something else. But instead, we're now checking the X. We will then. Oh, look! I can just do this. Steal another line of code because I've already wrote it. Oh, guess what? We can do this as well. Do we want to check against game object first, and then area? Yes, because the two operations are different. Yeah. Checkpoint. Would only check if it's inbound. It would only check against game object. So, in fact, I probably want to change the name of that to be a bit more. Precise. What we can do though for now, we will steal all this. So we will break to all done if it passes. A minute. Whoa. Hold your horses. If you're going to copy paste, actually copy paste everything. Don't. It would help if you actually jumped to the subroutine which checked the collision rather than just not. Someone beat. What did we beep about? Oh, thank you very much. Hello, Eternal Wild Fox. I hope you are well today. If you're wanting a bit more information about what I'm doing here, we got Spectrum going. Nice. If you do exclamation point Megaprocessor, it's in the stream title. That'll give you a bit more information. I'm doing all right today. This is my first time doing a dev stream, so it's a bit. But, you know, there you go. So, programming is generally my day job. Not this type of programming, but programming with a more modern language like C++, for example. This is my first time I'm really using this, so it's a bit of a learning experience for me, and it's a bit weird people watching me code, but I'm going to use it. It's Fred. Oh, I lost them. How are you doing, Fred? Can I get a shout for Fred, please? Fred's a bean. Fred, you can do it yourself, actually. Right, where was I? Okay, I was updating the ball. Got a collision on the X. We want to reverse the X speed and place the ball back. So we load in X. We then negate X. We then store it back. We load in ball's current X. And we store it into the Why am I doing that? What's your game, Vitruvian Man? Why am I doing that? Why am I doing that? That doesn't make any sense. Oh, no, I'm restoring the old information. That's what I'm doing. Okay. Yeah. I'm instead of using the updated coordinates, I'm restoring the old position, but it's now pointing in a different direction. Right. I did write. I promise you, I did write this code. This is my code. I did write this. Assembly is fun. I'm enjoying it. You probably might not have been here earlier, but I play a lot of the Zachtronic Industry games, which have a lot of assembly-like programming languages in them. So that's my only real experience with them. And I thought, why not? Give it a go. Thank you, Joe. Thank you for the raid as well. Thank you for dropping in your community. I like Lassine playing art. Just art. Yeah, you should check out Joe. Artist artist. So now we are checking to see whether when we're moving left or right, we are hitting something which exists in the game world. The problem is that's not quite everything we need to do in the X direction, because we also need to check where we hit a wall, which isn't a game object. Technically speaking, we could draw a border around the entire screen to contain it and then cheat that way. But that causes more problems down the line when we start to redraw the screen when a ball hits a block and it needs to disappear, because it might accidentally erase parts of the wall. We then need to check where we need to put the wall back. It's messy. It's easier just to check where it collides with the wall. But for now, let's look at the draw code for the screen. What's the best way to do this? This clear loop. Way to do this. So what row does the ball start on? The ball starts on X13. Oh, no. 60. No, it's paddle. Where's the ball? Ball starts on Y50. Okay. So what I want to do is want to load byte R0. Well, we want to load into R0. That's not even the right. Okay, we want to load it with the value 0. To load byte R1 with the value 50. We then want to jump to the subroutine, draw point. This is a little hacky, but this is just to test whether it works or not. Last one is 8, 16, that's 31. No, that's 21. 31, right. What I'm going to do, I'm going to save here, and then I'm going to compile and see whether we get an error. We don't get an error. I mean, you can't see that because for some reason, OBS cannot capture from a command prompt window. It's hard coded to not capture from that window. It's probably some sort of security issue, but that's fine. You last wrote assembly code 20 years ago. Wow. What was it for? Do you remember what processor it was for? Usually when you're writing assembly code, you're writing it for a particular piece of hardware. 20 years ago, that would have been 2002. Oh god, 2002 is 20 years ago. Oh no, I'm old! Right, anyway, sorry. Thanks for the bonk. Just for a microcontroller. Right, okay. 20 years ago. Sorry everyone. Right, let's go back to the Megaprocessor over here, and we will halt this code. We will load the new code, and we will run it. Let's see what happens. So I'll get ready with the halt. But Shift F. Shift. All right, okay. It drew the 2 dots. The ball is still going up and down. But it didn't crash. So we're 100% successful, but we didn't crash. And I'll take that, to be honest. Let's switch back to the code, shall we? So, why did that not do its thing? So let's see what we did. We initialized the variables. We loaded 1 into the X, 0 into the Y. Okay. Let's check the. We may have copy pasted too much code. That might be the problem here. Yep. There's the mistake. Right there. I copied the value of ball speed X into R1. Sorry, I added it to R1. R1 is storing the Y coordinate. Again, too much copy pasting. That now adds it to R0, which stores. I'm pointing the wrong pinging way. Or Y. X. I swear I know what I'm doing, chap. Kinda. So, now it should move in the right direction. Again, I'm throwing the word should in there. First off, does it compile? The answer is yes, it does. Right, let's switch back over to the simulator. We will reset just in case, load in the new code. Run. Again, we're clearing. We draw everything. Yeah, there we go. It's moving. It's moving. Let's see what happens. Boop. Wait. What? I swear something went funky then. Boop. Bounce. Oh, no. What confused me there was I'm looking at it live, and then when I went to talk to chat, I was looking at the past version of the screen. I thought something went wrong because I'm looking at the old version, like the one from 10 seconds ago. So if you don't quite understand what's going on, there's a little dot that's bouncing backwards and forwards. So it's capturing my mouse. Yes, it's here. Here. So before the ball was going up and down, it's now going left and right. So when it hits one of these dots, it goes, there's a collision, we bounce off it, head back the other way. That's exactly what we wanted to see. So now, if it bounces and hits the side of a brick, those things up here are bricks, by the way. I know they don't look like bricks. They're bricks. Look, when you're doing the graphics like this, you have to use some imagination. They're bricks. Sorry, I'm looking in the wrong direction. The problem is, the simulator's over there, and I need to look this way to make it look like I'm looking at the screen. So apologies. What was I saying? Oh yeah. So now, if it hits the side of a brick, we know there's been a collision, and we can do game logic based on that. Was it the side? Was it the side of the paddle? You do if that's the case. No, you still lose. I think. That'd be mean. Edge case, we'll do it later. Get game working first, then deal with edge cases. So now we have horizontal collision done with objects. Ideally, we need to check whether it bounces off the actual sides of the screen, which is what we need to do next, I think. So let me halt this so it's not running in the background, and we'll go back to the game code. Or you may notice that I'm just writing this in a Notepad++ window. No fancy code needed. So if you wanted to do this yourself, very accessible. No special tools are needed other than the ones they give you, the emulator and the compiler. Or you could do this in Notepad if you really wanted to. I use Notepad++ because 1, dark mode, and 2, it actually has pseudo support for assembly language source files. So that's why some things are colored differently and are bolded, because it knows that's a command. So it was like, I'll make that different. It's not very different, but it's good enough. Yeah, we'll take it. So now let's see if we're going to make it bounce off the sides. I'm going to refactor this code slightly. It's a bit. It will use the. We'll still call it update ball. But the first thing we want to do is we want to jump subroutine and return. Check ball Y. Object. It's clunky, but it'll do. Oops, that's definitely not the right thing. Must be X. I don't want to break here. I do want to do it this way. You see, this is... Right, so... Check ball Y balls, we'll call it. There's a lot of checking balls, which, by the way, you should get in the habit of checking balls. Just saying. Your own health, do it. Okay, again, I'm going to put a NOP in there in case I don't write something in there and it crashes the compiler. So we are jumping here if it's not. So again, we'll load in the balls. So no, it's actually stored in here. So what we want to do, let's grab this. Sorry, I'm currently trying to write things in my head before I do them so they don't look dumb. There's a better way of doing this. I'll probably refactor this off screen. Let's... I don't know, we've already erased it. So what we want to do is actually we want... We're loading the new values to check. Oh, we should... No, sorry, I'm... Load word R2 speed X add R1 R0 R2. Yeah, so I don't like doing the Y first. I'd rather do the X first, and that because X is. Sorry. We load in X, load in Y. We then update X, update Y. We then store it in ball check. Do thing when win game done. You're a genius. How do you do it? So in fact, we don't need to do this anymore. Wait. Let's get rid of this for now. We're going to see whether the code still works. This is the more important thing. Does the code still work? So let's run through this. Okay, we get the X and Y. We erase it. We then update X and Y and store it in this check variable. We then run checkpoint. If it passes, we jump to check ball X. Let's assume it doesn't for now, so we can continue down here. We negate the current speed in the Y direction and change it. We then load in the old X and Y coordinates, because we've not updated those yet, and store them in check. Really? That... You can then jump. Hydro, thank you very much. Jump. Update ball done. The reason why we want to do that is if it's already been a collision, thank you for the dots. If there's already been a collision, we don't need to check the other coordinate. We just assume there's been a bounce. And the ball will stay where it is, but with the Y direction change. And then it will attempt, oh god, all the effects. What we've got, Covas, Transspectrum, dots. Oh, thanks, Jodak. I've actually got a button here that will fire them all off. I just realized that. Oh, and now 8-bit, sweet. Every chance you get. Hi, Hitchhiker. Hope you're doing well. So yeah, we jumped to ball done because we don't want to check the X direction. If there's already been a collision in the Y, I don't think. There's probably an edge case where we need to do both. We'll deal with it later. So, if there wasn't a connection in Y, we then jump to X. We then load in the current coordinates to check. We then check it. Oh, wait, no. Ooh. No. Shit. That won't work. Because we need to know whether it was an X or Y collision. Now, checkpoint just says, was there a collision? We don't know which direction it is, so we do need to do one direction before the other. I'm going to have to carefully undo. That was 31. Right, okay, we're back where we were, where the code worked. Everything was fine and dandy. We're good. Collision code is always a pain. I mean, I could just surround the thing with it. Cause brick problems later. I don't really want to do that. Okay. Checkpoint. Okay, checkpoint. EMI. Oh, just hang on. Just testing the negative flag clear it. I don't think it does. No, don't do it that way. We'll do it this way. We'll check Y first again. Check Y. So first off, we'll load. I don't want to do this. Load byte R2 with 0. Made of purest green. Do I have what's in my hand? Purest green. I love Blackadder. Blackadder's so good. Okay, so we load 0 in there. Okay, let's have a look at the instruction set here. Apologies, this is so bright, it's burning my eyes too, but like I said, no dark mode website. Let's have a look at the instruction set. So we have, I don't want to, I've already got it. What are you doing? Let's find the compare commands. Okay, there's like, let's see what the compare command does. Nope. There we go. Comparing two things, it does RA minus RB. Result is discarded. The source and destination must be different. Okay, you can't compare a relation to itself, basically, is what you're saying here. So let's go back to the code. So it does RA minus RB. So compare R0 R1. It does. So that's wrong. We want to do R2. Or do negate R1. Probably want to make my own flag to say there's been a war collision here, to be honest. Let's add another variable. All. It's a bit wasteful to use an entire byte for this, but never mind. We want this to be a byte. Okay. Is this ARM assembly or one instruction set? This is hello, Miss Tran. I think that's how you pronounce that name. And hello, Sticky as well. This is assembly for the Megaprocessor. If you do exclamation point Megaprocessor, there'll be a link in there to the machine I'm writing the code for. It is a one-of-a-kind thank you, Fred. It is a one-of-a-kind processor. But yes. Where was I? I was what's the don't like the way I'm doing this now. I've looked at it again. I mean, all assembly languages look similar. You're not wrong. You can look at any assembly language. You can be like, huh, I wonder what processor this is for, or I wonder what architecture this is for. I'm sort of familiar with Z80 assembler. I've not written it, but I have looked at it a lot. 6502 assembly as well. I've looked at a lot, but not used. I don't even see assembly, but just blonde, brunette, redhead. Great film, Matrix. Love it. In fact, what we'll do, we want to load byte R0 with not 30, and then store word. What do I call that pinging variable now? War collision. R0. Oh no, it's ret, isn't it, in this language? I was ready for it that time. You don't know whether to cry or wet yourself. Do both. Just I've seen the machine in person, and it's an impressive bit of kit. The demo they've got running there is significantly more advanced than what I'm writing here. It's actually, they've got Tetris running on that thing. I actually have the Tetris code here. It's way beyond what I can kind of follow it, but it's way beyond what I can write. I just want to get something running on it, to be honest. I don't know how many people have actually tried to write code for that machine. I don't know whether I'm the first. I don't know whether I'm the second. I don't know. I'll ask when I go there, I guess. Oh, no, I actually want that to write B1 because it's failed. Right, so in check wall, the first thing we want to do actually is clear that variable, right? The clock rate, that's actually a good question. I know actually on the machine, there's a dial that you can change to change the clock rate of the machine. So you can slow the machine all the way down so you can view the panels better to see what it's doing. I don't know what it clocks up to. I can't remember off the top of my head. There will be an upper limit, obviously, because the bigger you make the components, the slower it is for a transistor and thing. Oh, is it a transistor? Well, for everything to turn on and off and things like that when you scale it up. So there is a upper limit, and it's not going to be particularly fast compared with modern processors, definitely. I don't know if it's even, it might even be measured, I don't know if it's measured, it might be measured in hertz rather than kilohertz or megahertz. I can't remember. I think it's more than, like, yeah, big equipment is slow to turn on, apparently. Yeah, sure, why not? Okay. Let's, load Word, I think it is. Ball check. Ball Y check into R0. Break. Right, I'm gonna have to look at the. Let's have a quick look at the instructions and check the break. Okay. BMI, that's the one we want. We want to break if minus. Again, sorry if I've burnt your retinas out there. I forgot to attenuate that. Alright, no, I want to keep it in lowercase. To wall check failed. Right, basically, it hit the ceiling. If the Y value is negative, it's gone off the top. Currently looks about 20 kilohertz. Oh, thank you for looking that information up. That's not bad, if I'm honest. That is not bad at all. I think the simulator runs significantly slower than 20 kilohertz, though. I think. I hope it does, or my code is running like shit. Flailed? Flailed? That's not how you spell the word failed. Programmers can't spell confirmed. Caught live in 4K. Thank you, Mousy. Can I get a shout out from Mousy, please? Who's looking after me? We like Mousy. Mousy's an absolute bean. If you like chilled streams of Final Fantasy 14, Minecraft, Stardew Valley, check out Mousy. Mousy's an absolute bean. Limber up to do some assembly. Yeah! Stretching my brain power, to be honest. Right. So we know that's negative. Okay, we'll load byte. R1, we'll load it with 816. I think it's 64 high. So this is trying to go off the bottom of the screen now, I think. Right, let me just check that is the right. Where's the paddle? Sorry, I'm forgetting my own terminology here. The paddle Y is 62, so yeah, 64 would be off the bottom of the screen. And then we do sub R0 R1. So, oh, no, we can do a compare there with that one. Do a compare. So that does the first one minus the second one. So if So let's look at the instructions again. Okay, we want to break it positive this time. Let's go back to the code. B. Is that right? So we do the current one minus 60. Oh, hang on. What does 0 come out as? No, let's load it with 63 and do R1 minus R0. And if that is negative, if we keep it to BMI, I think it'd be a bit more consistent. That's also a fail. So let's check the top and the bottom. So it's a bit hard to keep you out on chat and code at the same time. So apologies if I do miss your chat. Do a bit more than 20 kilos, I guess, spreading the thing over so much space might cause noise issues. I suspect that might be a problem because there's a lot of wiring in those things. So yeah, when you get over that much distance, the speed that the signal goes along that cable actually matters. So yeah. And also, in the computing museum, because some of those things are... some of the computers they have there are old, they are electronically noisy and sometimes poorly shielded. So there's a chance that there's a lot of electrical noise in that museum anyway. In fact, if you're young enough, you will be able to hear the sound of the transformers and the CRTs, the high voltage electric. You can hear that the very high pitched noise. It's just still within my threshold of hearing because I've looked after my hearing quite well. But Hitchhiker does a brilliant impression of a CRT monitor there. We're going to load Word X. We can do the same again. We check whether it's negative. That means it's going off the left-hand side of the screen. We will then load R1 with... I might have to split these up into check wall X and X check wall Y. Thinking about it. I'm going to do that. I'm going to split that up into check wall X and check wall Y. We still want to clear the collision flag, so we will borrow that code. FTL soundtrack is such a bop. It really is. Rename your subroutine. How many pixels wide is the screen? Let's have a quick look. 8, 16, 24, 32. Okay. That is not the right thing. So we load this with 31. And then we can do the same trick here. Again, this is wasteful in an entire byte. If you were wasting an entire byte just to store one bit back in the old days, you'd be shot. Right? How dare you waste 7 whole bits? How much is this code? I don't know. Oh yeah, I mean, if you declare a boolean in a modern language, it probably just uses an entire word. You're not wrong. It's probably, yeah, sure, whatever. We got gigs of memory. It's fine. Yeah, we only store 1 bit. What are you going to use? 32 of them. I mean, I used to work on RuneScape, and we used to, when storing data, we had to use every bit of a variable, or try to use every bit of a variable, because every var we added increased the player save size. And obviously, when you multiply that by the number of plays in the game, that starts to take up a bit more room. So they were very precious about using variables for players very carefully. Okay, where were we? Okay, so we're checking wall X, we check wall Y. I am only going to use this one for now. For yeah. If you're transmitting data, then you want to try and pack it as small as possible, and then if you can afford, compress as well before transmission. But yeah. So let's see if, I mean, this code isn't being called yet at all. So in theory, we haven't changed anything. I'm just going to try a quick compile and see what happens. 2 errors. Uh-oh. Uh-oh. You just cut there. Good. I think this is currently smaller than the Tetris code. So I'm going to assume it does. Also, there are a few mistakes on that website, by the way. I've already noticed some. Probably because it's written by a programmer. Therefore, we don't like writing things, so we tend to just make mistakes. We like writing code, not our Alright, okay, so where's the error then? Move code, draw code, update ball, check ball X. All done. Checkpoint, check ball. 11. Bad operands for opcode. Ooh, I stole that as a byte, not a word. That's where that's wrong, I think. Wait, hang on. Just check that. What was it? Bad operands for load word. Or check. Yeah, that should have been store byte. Okay, that's wrong for a start. That should be load byte. That's odd that. Are you going to compile now? Sorry, I can't show you the compiling process. Like I said, OBS won't capture the window properly. Bad operand for opcode. Oh, it's not. That should be store. That's why. No, it's not loading. You're storing. Right. Okay. That compiled fine. Some mistakes in the API. Nah, never happens. I quite like writing in assembly. It's an interesting challenge. So, I would like to improve the simulator, though. This thing isn't... It has a few flaws. 1, mouse wheel won't scroll windows. 2, no dark mode. 3, I think it runs too slow. I'm not entirely sure, but I think it runs slower than it should. But it'll do. It's the only one I have, so it will do for now. So, I'm going absolutely jumping all over the shop here. I apologise. No, let's not do that. Let's not do that. Sorry. Yeah, it has division and square root. Yeah. It has some really nice commands in it. I pointed out that it has square root right at the start of the stream, actually. The division is very interesting. It takes the registers 0 and 1, divides one by the other, then stores the remainder and quotient in the other 2 registers, which means you've got the modulo right there as well, which is really nice. But it uses all 4 of the system registers to do it. But that's better than doing it yourself, so I'll take it. Okay, yeah, there's some optimizations I can do here. What we'll do is we'll then load byte into R0 or collision. So we're checking the flag to see whether it... Well, we'll load it in. Break. Sorry, I need to check the instructions again because I can't remember the break commands. Break if Z is set, because yeah, okay. I think I've got this. Maybe. Yeah. So BEQ. All update done. If we don't break, we need to do this bit of code again, which is what I was trying to do earlier. you can fall straight through into that. Those are actually yeah. I'll rename that better actually. That should be wide. That wall collection. Okay. No, actually, you just want to fall. You want to jump to check ball X now. You want to jump to here. Oh, this is spaghetti. Apologies for anyone that's written assembly and is looking at this going, this is spaghetti. Yeah, I know it's spaghetti. Tasty, tasty spaghetti. Okay, so actually probably want to do that in the correct ball Y. And we want to do that in the correct ball X. Okay, let's run through this kind of fine. We're going to assume the subroutines work as they're supposed to. They probably don't. I have seen 6502 code. I made a basic Atari 2600 emulator, so I have seen 6502 code. What? I know the processor in the Atari 2600 is a 6507, but it's the same instruction set. Mostly. Yeah, the 6507 is a stripped down version of the 6502. So it has the same instruction set. Alright, okay, so we get the balls X or Y, we erase it. We load in ball X and ball Y again. We then load the speed in. We then add the two together. I don't know what's entire word. That could probably be a byte. I'll probably correct that later. Self-modifying code. No, thanks. So we add the two. We then store it in the checks. We then check whether it's collided. Then break if it's not equal. Okay, if it isn't, it corrects. So we jump to here. We know we've already hit something, so we're correct. No, we've collided with the. We've collided with an object. We're now correcting for it. We're going to assume that works. It then falls straight through checking the X, which it doesn't need to do. I only want it checking in one direction at first, so what I wanted to do there is jump. Update ball done. and then we update the variables and store it. Okay. If we pass that check, it now tries to check the wall. It then runs the wall check, checks the flag, and if it passes, it jumps to check that. If it doesn't, it falls through to here and corrects. It then goes through the normal stuff. Okay, now we're in the check Y, so we do the same thing again here. We check the point, checking the X, and reverse the speed. By doing correct that, it goes down there, and then updates and checks if it... No, that now needs to go to here. So now we check the wall. Check the wall collision, the X, check the flag, and if it's everything's fine, we jump to ball done. If it's not, we fall through to ball X, where we correct it, and then we return. Sweet. Let's see how many compile errors we get. No errors. It's kind of sus, if I'm honest. There's no way that compiled fine first time. Something's wrong. Whether it works is another question, right? I know we're a little bit over the 2-hour mark. Normally we go and raid Fred, but I want to see if this works first. If this doesn't work, oh well. If it does work, yay. Right, first off, we need to get rid of... No, we'll see whether the ball still bounces off objects. It's set up to do that now. So let's switch over to the simulator. And... ooh. That's... that was weird. Right. Oh, all right. Okay. Right. We will load. We will reset. We will run. Let's see what happens. Okay, it's drawing the board. Okay, oh, that is very much wrong, and it crashed. Okay. Let's do a quick look at debugging here. Let me just try and find where I want to put a... Okay, so if we do... Oh, I can't scroll, can I? Ah, blah, 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 blah. I'm looking where I want to put a breakpoint here. Beef. Okay. I think it's here. No, the next command's a jump. Yeah, that's not the right place. That's too far. Right, okay, it's there. Right, so what I'm going to do is I'm going to reset. I'm going to run, and when it hits a certain point in the code now, it will stop execution right there, and we can see what's going on. I think it's F10 to step. I'm going to pull up assembly code on my other screen so I can have a look what this is doing. What this is supposed to be doing. So this is checking input now. Welcome back, Jedi. We're about to go raid. I might have to do some quick debugging off chicken nuggets and tasty. What did I have? I think I had pasta and pesto sauce tonight. why are you loading 64? I probably did tell you to do that, but why did I tell you to? Oh, right, that's the flag. Right, okay, yeah. So it's still checking input at this point. The move does something really weird, which is my main concern. So let's see. So the ball should disappear at some point. Next game tick. Oh, that could be a while. Yeah, it's stuck in the execution loop here for the input check. GSR update ball is where we want to be. Update ball is 10F. Yeah. Right, there we go. Don't worry about me, Darkady. If you want to drop modding someone, you know that you're always a volunteer here, so if you don't want to do it here, that's fine. Don't worry about it. Okay, so now we are erasing the ball. Should disappear in a moment. Should have done. Right, okay, I think this is going to take me too long to sort this out. We did get the ball bouncing backwards and forwards between objects before. It's just the refactoring is screwing some stuff up. I'm going to try and sort that off stream. Hopefully get set it up. I don't know if I'm doing another one of these. Yeah. All mods, you're great beans. I have 3 mods, I believe, in my channel. But every mod in every channel, generally speaking, is doing a good job. Thank you. Streamers love you. I'm going to set up the raid now. I'll fix this. I don't know if I'll be doing... 4 mods. The reason why normally on Wednesdays I do a VR stream, but what with the temperatures in the UK being wild right now, I didn't want to risk tonight being particularly warm and then doing a VR stream and then making myself ill. So thank you, Stretch. It's a good point. Malp is also technically a moderator. You're all right. There's 4 mods. Normally on Wednesdays, yeah, I do a VR stream, but I wanted to do something where it isn't temperature dependent. So we might be doing this next week. We might not. I might try and switch out another one of my streams to do it another dev stream, because I have enjoyed doing this, but I like to stream VR because VR's where my passion is. Well, this is also my passion as well, programming, but I also like to stream VR. Plus 2 games which I stream VR in have had updates since I last streamed them, so I want to stream them. So keep an eye on my Twitter or in my Discord for the schedule. If you're only interested in programming stuff, that's fine, not a problem. If you want to see me play some VR games, cool, stick around. But for now, let's go say hello to Fred. I think he's working on BeepoBox tonight, which is his VTuber interaction tool made in Unity with C#. So if you like programming, you probably want to stick around because we're going to go see some more. Let me set up that raid now. He better be live now. I've bigged him up. thinks he is. Let's go say hello, shall we? Thank you for watching tonight. This has actually been a lot of fun, a lot more fun than I thought it was going to be. Hopefully I'll fix this problem, and then I'll probably put an update on my Twitter saying, hey, we fixed it. I'll post like a gif of it working or something. I'll be back on Friday with some Into the Breach. We've got a playthrough of that running right now because it added a whole bunch of new content. But for now, let's go say hello to Fred. Fred's good bean. Let's head over there.